Encoding seasonality with Fourier terms. Welcome! In this lesson, we will learn how to use Fourier terms for handling seasonality in time series data. By the end, you will be able to create new features based on sine and cosine waves to help models recognize repeating patterns. Let us begin our journey into this useful skill for time series work. What is seasonality? Seasonality means a pattern that repeats at regular intervals, like higher ice cream sales in summer months or holiday shopping surges. Many time series, such as weather or sales, show seasonality. We can help models understand these cycles by creating special input features. First, let us import code libraries. This line will turn off computer warning messages to keep the notebook tidy. We import key tools to work with data, numbers, and plots. Pandas helps us handle data in tables. NumPy provides functions for math and arrays. Matplotlib lets us create charts and graphs. Try running this cell before moving on. Let us get a real dataset to work with. Our data is monthly airline passenger numbers from 1949 to 1960. We set the URL of the file. Now we load the data from the web using pandas. This prints out the number of rows and columns in our table. This displays the first few rows so we can see what our data looks like. What do you notice about the data columns? Try exploring below. Dates in our dataset are just strings right now. Here we change the month column to a special date format. We tell pandas to use month as the table's index, which helps with time series. Now any row can be found by its date. Let us peek again at the first rows. Try finding the date for the first row in the table. Let us visualize the data to see if we can spot any cycles. We create a rectangular plot window. We draw a line for the number of passengers over time. Let us give the chart a title so it is clear. We label the vertical axis as passengers. We add a label for the date at the bottom. This shows the final chart. Look for repeating up and down swings. Do you see the yearly pattern in the chart? Why use Fourier terms? Fourier terms turn repeating time patterns into smooth waves using sine and cosine functions. Many models cannot use the date itself, but they understand numbers like sine and cosine. With these, patterns like yearly or weekly cycles become easier for a computer to learn. Let us assign a number to each month, starting from 0. We are giving each date a simple number, like 0, 1, 2, and so on. This helps us use math functions based on how far we are from the start. Let us look at the first rows to check our new T column. Notice how every row gets a unique time value, even for missing months. Now we add our first Fourier features. This period means how many months before the wave repeats. We use NumPy to make a sine wave that runs from -1 up to 1, lined up with the months. We make a cosine wave too, it starts at its top value instead of 0. Both waves repeat every year and shift up and down together. Let us preview what the new features look like. Try changing the period to 6. What do you think will happen? Let us see what the sine and cosine waves look like across our data. We make a new plot window. The blue line is our first sine wave feature. The orange line is our first cosine feature. Labels make it clear which line is which. Adding a legend helps us tell the waves apart. We show the chart so we can easily compare the cycle shapes. Sine and cosine make smooth, regular curves. That shape is perfect for modeling cycles. What if we want to capture more complex patterns? We set how many extra sine and cosine pairs we want to make. We repeat for each new wave order, starting from 2. We add a new sine wave that wiggles more often in a year. We add a matching cosine wave for each order. This lists new columns for higher frequency waves. These catch smaller, fast cycles. Try increasing the order to 3 or 4 to get even more details in your features. Let us look at all our Fourier features at once. A large plot window will fit many lines. We go through each sine wave we made and plot it. For each one, we plot the matching cosine wave as well. A legend helps us find each label. We put them in 2 columns for space. Now we see how basic and detailed cycles can be combined with Fourier features. We show the plot with all the lines. See the repeating stripes? How might combining these patterns help a computer model? Now let us use these Fourier features to fit a simple prediction model. We load a linear regression tool from a library called scikit-learn. X holds all our sine and cosine features for every row. Y is our real-world data, the passengers column. We make a blank model. We teach the model to connect our features to the real data. We use our model to guess or predict the passenger numbers. Now we plot both the real values and the predicted values. The blue line shows true data. The orange line is our model's guess using the waves. The legend separates both lines, so you clearly see them. A chart title gives quick context to the plot. This shows if the model can follow the seasonal patterns. Try making a line plot showing only predictions. What changes do you see? Real-world example, why Fourier? Sine and cosine can describe any repeating pattern, whether it is sales at Christmas or more flights in summer. They help even simple models find and match cycles that would be hard with just a date. These features are used in business forecasting, weather prediction, and more. Let us compare what happens if we fit a model using only the time step, not the sine and cosine features. We make a second model. This model only sees the step number, not any wave shapes. We fit it just like before. We predict with the new model. Now make a plot as before. The blue line is the real data, the orange is how the model guesses without wave features. The legend helps us compare both results. A title to clarify what we see. This shows the model cannot follow the up and down swings of seasonality as well. What is missing from this model's fit? Try to answer in your own words. Let us get you involved. We ask a question about calendar cycles to help you think about periods. This line brings up a box to type your answer. The answer you type will be used in the next line. We print out the period using what you entered. Try giving different answers for months, then predict what would happen if you changed period. Ready for a challenge? Here, we make a new sine wave, but with a 6-month cycle instead of 12. We plot it to see how the shape compares to our first features. The curve repeats twice a year, catching patterns like spring and fall. A clear chart title reminds us what period we are testing. The plot comes up to show your new wave right away. Try changing the number in the formula to create even shorter seasonal cycles. Let us explore how different period values change the cycle. It is best to experiment with several periods to match your real data. Here, we test 3 wave cycles, every 3, 6, and 12 months. For each, we make and plot a sine wave with its period. Labels help compare the waves on the chart. The legend keeps the lines clear. The title shows what we are comparing. Now we can see which periods best line up with your data's true cycles. What do you notice as the period gets shorter? Here is a coding tip for when your projects get bigger. You can automatically create Fourier features using scikit-learn's function transformer. This lets you add waves directly into machine learning pipelines. Here, we define a helper function to generate as many orders as you want. Each new order makes 2 columns, one sine and one cosine. The function builds all features together. Now we show how to wrap it with Sklern's transformer tool. Calling fit_transform applies the function to our data to make a big table. The shape command tells us the rows and columns in our new feature table. Try changing period and order above, then check how many columns you get. Here is something to watch out for. If you use too many sine and cosine features, the model can start chasing noise, not true patterns. Let us set the order higher, so we have lots of waves. We fit another model using this bigger feature set. We predict just as before. Now look at the plot. If the dashed line gets too wiggly and hugs every up and down, that is a sign of overfitting. This means the model memorizes random ups and downs that may not repeat. A legend and title keep the plot clear. Seeing real and model lines together helps us spot when things have gone too far. Try lowering the order back down. What difference do you see? Recap: Fourier for seasonality. Seasonality means repeating cycles like sales or temperature. Fourier terms give us wavy features using sine and cosine. Models use these waves to match peaks and valleys in real data. You can use as many orders as your cycles need, but watch out for overfitting. This skill works in forecasts for business, science, and beyond. Now practice and subscribe. Try adding Fourier features to your own time series dataset. Change period or order and see what cycles your data contains. If this was helpful, subscribe to the channel and let us know what you built. Thanks for learning with us. Try making a plot with your own Fourier feature.